For 150 years, our map of Neanderthal origins has been wrong. We told their story as a local epic, Europe's tough survivors born and buried under limestone and ice, but ancient DNA just torpedoed that entire map. I'm Bob the historian, and this is Beyond Known History. The earliest Neanderthal trail doesn't start in the west. It points farther east. Not a single birthplace, but a braided river of migrations, swaps, and comebacks. Tonight, we follow that river through caves in Spain, tunnels in the Caucasus, and a Siberian genome carrying a Denisovan whisper. Forget the evolutionary ladder you were taught. This is a network, and the newest genomes are finally showing its shape. Here's the problem with origins. Bones don't come with passports. Neanderthals split from our common ancestor about 600,000 years ago, often modeled as Homo heidelbergensis. After that, the footprints scatter, from Iberia to Siberia, across glacials that shove and interglacials that tug. The fossil map is a jigsaw with missing edges, a skull in one cave, teeth in another, tools everywhere. And not just one style, hand axes, prepared core flakes, all jumbled together. The timelines blur because the Earth itself is a messy historian. Caves flood, layers rework. Volcanoes dust everything with ash, scrambling the clues. For decades, we argued, did Neanderthals start in Europe, then radiate east? Or were there multiple waves, pulsing into Europe from a wider Eurasian engine? Climate kept remixing the cast. Small bands split, drifted, met again. By the time we wrote a neat ladder, the ground had already shifted under it. We needed a tiebreaker stronger than bone shape. Ancient DNA was supposed to be it. For years it wasn't. Too degraded, too few samples, and then a handful of high-coverage genomes cracked the door. Then, the genomes landed. From Denisova Cave in the Altai to Vindia in Croatia, high-coverage DNA revealed the truth. Neanderthals weren't one tidy branch. They were structured, split with clear east-west differences. And at Denisova came the bombshell, an individual with a Neanderthal mother and a Denisovan father, a first-generation hybrid. Not rumor, not maybe. A literal bridge between lineages carved into bone. Set that beside the Altai Neanderthal genomes, and a network takes shape. Eastern Neanderthals mixing near Denisovan territory, Western Neanderthals following their own path, and pulses of contact whenever climate opened the corridors. The takeaway? Origins stop looking like a dot on Europe and start looking like traffic, surging across Eurasia. So let me ask you, if you had to survive an ice age, what's your edge? Genes, tools, or alliances? Split the map in two. West, Spain's Cima de los Huesos fossils, older than 430,000 years, already carry early Neanderthal traits. Later genomes from places like Vindia and El Cedron show the classic Western profile. East, in the Altai, Neanderthals live on Denisovan borders, and their DNA remembers it. Different neighbors, different exchanges, same family, diverging stories. Ice Age Europe acts like a conveyor belt. Glacials shove bands south into pockets. Interglacials pull them back north. Each push-pull scrambles the cast. Some groups mix, some replace, others hang on in refuges for millennia. So instead of a single origin arrow marching west to east or east to west, you get waves, overlapping, retreating, returning, rewriting the tree each time climate flips the switch. Draw your eyes to the Caucasus, mountains that look like a wall on the map. For Ice Age people, they were a corridor. In Mezmaiskaya Cave, a Neanderthal infant's genome tells the story. It doesn't point cleanly west. It carries echoes that tie the Caucasus to eastern Neanderthal lines. A reminder, bands didn't stop at ridgelines. They threaded passes, traded mates, swapped ideas. Across millennia, climates toggled, and the corridor opened and closed, like a valve. Each opening brought new pulses of Neanderthals. Some moved into Europe, some moved out. Sometimes they replaced earlier locals. Sometimes they mixed with them. This was not a moat, it was the switchboard of Eurasia, a place where signals leapt between continents. The takeaway? If you're still drawing borders, flip your pen, draw arrows. And here's one for you. Which shaped human history more? Mountain passes or rivers? Pick one and make your case. We used to park the big encounter at 60,000 years ago. Our species leaves Africa, meets Neanderthals, swaps genes, and moves on. True, but not the whole film. The genomes point to earlier exchanges too, at least one pulse around 100,000 years ago, likely in contact zones that opened when climates warmed. Not a single handshake, but recurring conversations across the Levant, the Caucasus, maybe even deeper in Eurasia. And the legacy sticks. Today, most non-African populations carry 1 to 2% Neanderthal DNA. Not museum pieces, but working parts, immune tweaks, skin and hair responses, bits of metabolism that helped bodies cope with new light, new bugs, new cold. They didn't simply vanish, they left code. Inside us, still running. So here's a spark for you. If you could keep exactly one Neanderthal upgrade, better cold tolerance, tougher immune response, or thicker skin and hair, what's your pick and why? By 40,000 years ago, Neanderthal camps thin out and then go quiet. Not a sudden cliff, more like a dimmer sliding down. The genomes sketch a rough picture. Late Neanderthal groups were small, dangerously isolated, a genetic bottleneck. With low diversity, every shock, a new disease, a sudden famine, a brutal winter, hit the entire group harder. They lacked a deep reservoir of resilience. Meanwhile, our species shows up playing a different game. We built bigger, wider exchange networks. Tools and pigments traveled hundreds of kilometers, which meant ideas traveled even farther, and mates moved between bands. That scale wasn't about being smarter, it was about being more connected. A crucial advantage when the climate began to whiplash. Did we wipe them out? The cleaner answer is messier. Some competition, plenty of assimilation, and a lot of bad luck for tiny populations living on the climate edge. Pieces of them fold into us. The rest fade as refuges wink out, one by one. Their story doesn't end, it merges into our immune genes, our cold weather tricks, even how our skin handles light, extinction in the fossil record, inheritance in the genome. So here's the cue. If you had to pick one survival superpower for an Ice Age band, mobility, alliances, or innovation, which one scales best and why? The newest genomes sketch something else, a braided river. Channels splitting, rejoining, sometimes vanishing. East and West trading genes across corridors like the Caucasus, meeting again when climates loosened their grip. And our tools for reading that river keep leveling up. Cave sediments with invisible DNA, dental calculus holding ancient molecules, microscopic residues on stone, telling us who used what, where, and when. Each new method adds another strand to the braid. So where did Neanderthals begin? Wrong question. The better one is, how did networks of small bands, ours and theirs, keep reshaping each other across Ice Age Eurasia? Because they didn't simply end, they merged into us, 1 to 2% in our genomes, echoes in immunity, skin, maybe even sleep and stress responses. Neanderthals aren't just a chapter we closed, they're code we still run. Here's my take. In volatile worlds, connection beats isolation. Bigger exchange webs, faster idea flow, wider mate networks. Those scale. That's the edge our species rode, and the reason their story still lives inside ours. Now your turn. If you could time jump to test one moment in this braided river, an early east-west meetup, the Caucasus corridor during a warm pulse, or the first contact with us, which would you pick and why? I'll pin the best pick, and if this rewired your mental map, subscribe and send it to the friend who still thinks evolution is a straight line.